Welcome to my channel Nature of Physics. Today topic is Malus Law, polarization of light. Malus Law I will explain with a neat diagram. So first, ordinary light or natural light is a unpolarized light, so that it has dots and arrows like this. This is unpolarized light, and alternate diagram for the unpolarized light. This is the direction of light wave, so it has arrows in the plane. This is the light, these are the arrows in the plane. And next, dots are perpendicular to the plane like this. So tip only we can observe. Okay, so the vibrations in the plane is arrows, and the vibrations perpendicular to the plane is dots. So this is a unpolarized light. Next one is polarization of light. Light which has the acquired the property of one-sidedness is called polarization. So in which light either dots or arrows it has. See that now this is a plain polarized light, so that it has only dots, nothing but vibrations perpendicular to the plane, or another it has only arrows in the plane which are light wave vibrating in the plane like this taking. So now this is a plain polarized light. Malus Law, definition, clear diagram and derivation. So first, this is the unpolarized light. It has dots and arrows, which is allow to incident on the tourmaline crystal. So first one is acting as a polarizer and another one acting as a analyzer. So polarizer and second one is a analyzer. When unpolarized light incident on the polarizer, dots has stop and arrows only releases. By tourmaline crystal we are getting plain polarized light. Only arrows, dots are stopped by the polarizer. Next, another tourmaline crystal is using for analysis. That's why taken as a analyzer. Initially, polarizer and analyzer both are parallel. Then whatever we got plain polarized light, that completely we will get here when analyzer and polarizer both are parallel. That we can discuss in the cases whenever analyzer get rotating making certain angle, then even arrows also stop. That's why the intensity of polarized light is decreasing by the analyzer. Finally, at perpendicular, analyzer is perpendicular to the polarizer, no light we will get. Already I told you, I give to you two cases. I naught is the intensity of the polarized light, and I intensity of light we are getting by the analyzer. See, this analyzer is making an angle theta with respect to polarizer. See, this is the parallel lines, so that analyzer is making an angle theta. Here the representation theta. So this is the axis of the polarizer and this is the axis of analyzer. So axis of polarizer and axis of analyzer making an angle theta. Theta is the angle between the polarizer and analyzer. Okay, so next one is, this is the light wave. So this is the light wave. Light waves are electromagnetic waves. The equation for the light wave, E is equal to E naught sine omega t minus x by c, in which, okay, E naught is the amplitude of electric field vector. E is the incident electric field vector of the wave, and omega is the frequency, x is the distance traveled, and t is the time, c is the velocity of light. So this amplitude of electric vector is E naught. This is the E naught, okay, along the axis of polarizer. This E naught is resolved into two components, see, like this. So taken like this. So this is E naught cos theta and this is E naught sin theta. And horizontal component E cos theta is a transmitted component of amplitude of electric vector, and E naught sin theta is a vertical component, blocked component of amplitude of electric vector. Now here I naught is the intensity of polarized light from the polarizer. Next, I is the intensity by the analyzer. So that intensity is directly proportional to the amplitude square. So intensity I naught directly proportional to the amplitude square E naught whole square. I naught directly proportional to E naught square. So this is taken as equation number 1. Next, I is the intensity of polarized light by the analyzer. So I directly proportional to the E naught cos theta whole square. E is taken as equation number 2. Here also intensity is directly proportional to the horizontal component of amplitude of electric vector whole square. So now equation 2 divided by equation 1. So I divided by I naught, which is equal to E naught square cos square theta by E naught square. E naught square is get cancelled. So I, which is equal to I naught cos square theta, is the Malus law, is taken as equation number 3. So intensity of polarized light through the analyzer is directly proportional to the square of the cosine angle between the plane of transmission of axis of analyzer to the plane of transmission of axis of polarizer. So I directly proportional to the cos square theta. So this is the diagram, explanation and definition of the Malus law. Okay, so just a second. Now two cases of Malus law. First one, see, this is the polarizer, this is the analyzer. So unpolarized light incident on the polarizer, okay, we got plane polarized light. Again we are getting plane polarized light when the analyzer is parallel to the polarizer. Here theta is equal to 0 and Malus law I am writing. So cos 0 is equal to 1. So then according to Malus law I is equal to I naught cos 0 whole square. So that I is equal to, we are getting I naught. See, I naught we go. Here Malus law is applying for the analyzer is perpendicular to the polarizer. Then theta is equal to 90 degrees. So this is the polarizer. Analyzer is initially parallel and rotating. And theta is equal how much here? 90 degrees. So that cos 90 is equal to 0. So Malus law I'm applying, so that I, which is equal to I naught cos 90. Cos 90 is 0. 0 into anything 0. So please watch my videos and like and subscribe my channel. Next also very interesting, including amplitude, I'm going to explain. That is the most important application of the Malus law, intensity and amplitude relations. Thank you.